Hi everyone. Today we will look at the hands-on practice on MySQL data definition language in command line. DDL data definition language can do to create a database, create tables, and also we can create users and grant the privileges, which can control the user access to the database. And also we can insert data into the tables. Authorization of data access, in addition to authentication, is very, very important to concept, not only in database, but almost all other areas when it comes to data the access. But in database management systems, depending upon the packages included in the DBMS, we may use some of the tools for authentication from the given the DBMS installations, or we need to do somehow ad hoc the coding skills to authorize the user access. MySQL does not have the tools for the authorizations, but we know in the later part of this class, not only simply using working on DBMS, we're going to do Python code to include SQL statements to manipulate and manage the database. So while we are using or implementing in Python, we can make some the software to authorize user access. That is a real advanced topic of this class, which can come later, toward the end of this semester class. So DDL can do create database. The language is, as you can see here, create. There's a reserved word. Database, that also reserved word, followed by your database name. Okay, this is, you name this database. After you create, then you need to select that database you create. So using the language use. So as you create the database, the MySQL prepared some of the file systems for your database management and manipulation. By using use, so you are now getting this database where you can create tables. So create table, followed by table name, and then open and close parenthesis, ending with this semicolon. And you need to include pairs of attribute and type, CWID and text. Of course, with this, you can define a primary key if you need to do. For example, CWID, if it is a number, then you need to put here int rather than text. And you can do primary key CWID. Before you end this, for example, then you can do primary space key, open, and then you can put here the attribute, primary key attribute. So in this case, maybe it's WID, and close parentheses. All right. And in the case of choosing an attribute for primary key, if that attribute is not integer but text like this, then because text is not really the standardized the type for database attributes. This is like a sugar syntax. You can use it in handy manner, very easy to declare. You don't need to say, I want to make a 13 characters or 15 characters, which is the type char. Char is the character, right? So char and 13 characters. If you don't think 13 character is always enough, then you need to say, for example, somebody's name is longer than 13 characters. Somebody's name is shorter than 13 characters. One thing, if you simply say char, then the size of these variables are always fixed, 13 characters long, right? Somebody has names in shorter space, then whatever the space unused, that much waste the computing resources, right? On the other hand, what if somebody is longer than 13? So to avoid that, there's another type called the varchar, variable sized the characters. So varchar and 13. Then initially, your database allocate the size of a 13 byte, 13 characters. When it comes to the longer name, somebody has a real longer name. I know some countries add their last name from their ancestors. So young generations might have longer the size, the last name. The size of the last name continue to grow. But anyway, this varchar, how it behaves on database, initially 13 characters long. When it comes to the longer size of that, then it doubled it. So 13 times 2, then 26 bytes. So it can accommodate. And also if it some names are longer than 26 characters, then times 3, the given size. So 13 times 3, then 39 byte long one. And then the other one is the times 4, times 5, times, so multiple of 13 is the size of that ones when we have a varchar. Okay. So you can use text or char or varchar, any one of those. So usually you can do text, but when you specifically to declare a primary key, then you need to do either char or varchar. Otherwise, it doesn't take as a primary key. Primary key in text, not allowed. Primary key in char, primary key in varchar are the legal type. And also you can create the users, as I already explained that. And then how you can create users. That is a language, create user. And then quote and unquote, that is your login ID. @ this is outside that quotations. And we open another quotes. This is the location, URL, if you declare that on the remote databases. When you use a remote database, then you need to um, have a network connection. Not only network connection, but you need to have some of the tunneling between your local machine and the database. Okay, so you need to set up the tunneling. We may practice that. Maybe when it comes to Python coding for database, then we're going to use not here only local. What we want to do, here's the scenario. We're going to use Python editor on Google. So Google Colab. I know some of you are familiar with that, but those who are not, don't worry. We will start from scratch. So we open up Google Colab. There's a collaborative coding, Python coding platform that runs on the Google server. That is a purely web-based. So open a web browser, and we can connect it to the Google Colab, and your coding is stored at Google Drive. So Python is running on Google side. Let's say your database, MySQL, I believe you guys already installed your MySQL on your laptop. Then your laptop is a remote database, right? Your laptop is with you, and your Python code is at the Google Drive. How Google Drive connected to your laptop? All right, that's what we are going to do. That's a tunneling needs to be established. But anyway, in this case, we simply use a local host. Okay, so create your user, your local host, and your the terminal will be open on your local, the same computer, same laptop. So it's not the issue. So this all together one word, although there is the quote and unquotes. And then we need to put the keyword. I'm sorry, password for this login ID, Jae-yoon. So identified by Jae-yoon. So you can. This is not really a strong password, but this is okay. Anyway, you are working on your local machine. But for your when you are the Google, your code stored on Google Drive wants to talk to your database on your local laptop, then there's a remote access. Meanwhile, maybe if you are using this simple weak password, then maybe hacked in, right? Technically, it is not impossible. You can strengthen the password. The reason I put this is a sample, number one. Number two, unless otherwise I forgot. I'm not going to put here the strong password. But anyway, so once you create your login ID, then the login ID, even if it is created on your DBMS, by default it doesn't do anything. So you can grant the privileges. If you want to grant the privileges, all the privileges, then you need to say all and privileges. Here is a plural. Don't forget that. If you want to put the selection only the access database or delete privileges or create privileges, then you need to put here that specific privilege. For example, create privilege, not plural, on, and then here is a database. This is first the name here. We have a dot notation. The prefix of this dot notation, that is a database, and then the postfix name here, that is a table. So you have a specific table on a specific database. For simple practice, if you want to give all the privileges on all database, all tables, then you can do star dot star. Okay. Again, in cybersecurity purpose, this is not really recommended, of course, but for our simple practice, we can do star dot star 2, and this is that specific credentials, same as that, and ending with semicolon. Database language, it should end with the semicolon. Why? We'll see that. Okay. Database expression is not really usually simple expression. It is longer and longer and longer. You can make one line on your terminal. You want to make another line to make sure that you see the language, that expression clearly well. So you may be able to write your SQL expression in pretty printing formats. Then you need to make a lot of, one expression may need many lines of code. Of course, therefore, you hit return or enter button. Enter button doesn't mean the initiation of the executions. Enter button in SQL statements to create new lines. Execution can be initiated only if you put semicolon and enter button, then your DBMS start executing the SQL command that you just entered. Okay. And the next one is, so here, for example, create user, JUN. You can, in this case, 127.0.0.1, this is a local host anyway. Either you can put a local host or 127.0.0.1. And identified by, in this case, different password, right? Probably I created the different ones, and then grant all the privileges on all the tables in all database to this user. You can make that way. And either way, if you use this or localhost, but I recommend you to use localhost first. This is the first option, okay? And then, yeah, if you have some issues. So what you need to do is you first enter as a root, and then you can create user. If you have an error, then you can, because of this localhost, if you have an error, then let's see, oh, this is okay. This is not really the issue. I think operation create user failed for JUN at the local host. Maybe that already exists. This is not really the things. You can remove that. So this taken well, user creation here. and then you can grant all the privileges, and then you can quit, and next time you can come in as the user that you just created. This is user ID, so you can do here MySQL minus u, this is your user ID, and minus p, and then you can enter that password, whatever that you created here. Then you can get the clear to enter into MySQL. Okay, and then you can insert. You can populate the data into a specific table, because you already you create database, and then you locate that database, and then create tables, then populate by using insert into statements, your table name, and then values. In between, you can specify the list of the attributes like this. If the list of attributes that you enter is the same as the order that you created, then you do not need to do this. You can simply say student values without this. But you must specify this if you enter the values not in the same order that you created, then you need to say, or not all the attributes, only the partial attributes, then you need to say, hey, I want to put here name first, date of birth, and then CWID. Major is not undeclared, for example. Then you need to specify that explicitly here, because it is not the same as defined. Okay, so this is what we want to do. All right, that's all what we need to do today. And by the way, I'll update the class notes, the lecture notes. Probably my lecture note covers a little longer than this. I believe that comes into database authorization. This authorization, as I said, we will do that further later. And then selection, from where close, all the SQLs, group by, auto by, where in, group by having, and nested SQL statements. But we'll do this later, but we'll stop that here. Okay, this is one other thing that I'm going to tell you. Once you grant the privileges, someone may questioning where that privileges information stored in our database. If it is MySQL, then it is in the MySQL database, and then table user. So MySQL.user, that is your table. So select start from MySQL.user, where user is Jae-yoon. Okay. Then somewhere here, the attributes user, and it keeps host, which host that this user can come in. And then somewhere here, the privileges, let's say here, the select privileges, yes. Insert privileges, yes. Because we grant all the privileges, so we need to check. Update the privileges, yes. Delete privileges, yes. Create privileges, yes. Drop privileges, yes. Shut down privileges, process privileges, file privileges. If you have a grant all the privileges, if you have that privileges, then you can grant the privilege to others also. So you are, let's say the privileges is granted to you. Therefore, you can grant the privileges to others. there's a cascading, there's a dependent of the privileges. So if you lose, your privilege is revoked, then automatically those who are granted by you will be cancelled automatically. There's a reference if you set up, for example, foreign keys, index privileges, alter privileges. Alter is another language. Once you create tables, table definitions, if you want to modify, then you need to use alter privileges. And alter routine, and this is some of the routines. Create user. You can also create another users. Event privileges, trigger privileges, create the table space, and more and more. Okay, so we'll practice this. What we want to do is we need to open up the terminal. If you guys are running on Windows, then you need to find out the file browser there, and then C drive. Then you may be able to see program files, and within that program files folder, you may see MySQL things, and that is the location of your MySQL. So find out MySQL, the path expression, and then you can use it. On Mac users, Mac file system is the same as a Linux file system. So you need to first go all the way up to root level. So root level on your file system is nothing but slash. So you want to change the directory, cd space slash. So now you are on the top, and then usr / local. Then what is my the path expression? That is /user / local. See what I do have. On this folder, I have multiple MySQLs. So I want to go to my recent versions. So cd MySQL -9 -9 dot 0 dot. There's ARM64, not x86, Intel 6 or x64. Mine is ARM. All right. So I changed into that specific MySQL, and see the directory. There is a bin. So I want to change another directory to bin, where I see MySQL here. Okay, this is MySQL. That is what I am going to do. So I want to go into, let's say, MySQL -u root. Remember that I asked you to remember root. On Linux, then MySQL, if it is not that path expression is not known by your Linux, there is export the command. I didn't do that. Then you need to explicitly specify which MySQL that you want to run. Then I can say dot, which means my current directory. In my current directory, there is a server file, which is slash. So dot and sub file, and then MySQL. Then this one can execute it. Then I can put my root password. And then let's say the database is already created. So show databases, then I have those databases available. So I want to create database first, and then I can say Cyber 525. That is a database that I want to create, and show databases. Then I have Sci 525. Okay, so we're going to use that once. So use Sci 525. Then database changes. If I want to see tables, of course nothing, no tables created. So now what are we going to do? We are going to, I believe, the previous database I put here, I believe this is it, right? So I'm going to create the tables like this. All right. So as you see here, I'm going to modify this a little bit. This is not really. Say student can be defined by CWID, name, and major. But major is not the value for the student major. It's not independent value. The value for this major attribute should be the value for the department ID. For example, if department ID is cybersecurity, then your major is cybersecurity. In other words, you cannot create student with a major value which is not available in the department, right? Of course. So what that means is that value for this major dependent on the value for this department. So department should first exist. So we need to create the department first, and then we can create the major. Faculty, I'm not going to create this. I want to make it simple, right? So we're going to make a student department, and then class and enroll. We're going to make those four. Let's say create table. Let's do student, for example, CWID, that is int, and name, I can say text, and major, that is also text. And then we can say primary key is CWID, comma, foreign key is major, which references. So on the other table, department D underscore ID. Let's say this is my creation for students. Of course, department does not exist. Therefore, it gives me an error, right? That's not available. So when you create tables, there's a certain order. When it comes to the referential, when it comes to foreign key constraints, and therefore mutual reference constraint exists, then you need to do take into considerations of that dependency issues. So we need to create the department first. Department can be created independently. Well, without students, department can exist. Without the class, department can exist, right? Before, let's say, university is established, then department needs to be created. Yet, there's no classes offered, right? That is such an order in the real world. That real world should be represented on your database. Therefore, that order influenced into our database creation as well. Okay, that is realistic. So create table and department. And department has name. If I say text, text is a primary key. No, DID is a primary key. D underscore ID, that is also text. Cybersecurity, that is the DID, right? And chair, that is text. And if you say primary key is DID, then you will have an error because, as I said, primary key, type for the primary key shouldn't be text. It should be char or varchar. Because I said here primary key is a DID. So DID here, if I declared that as a text, then you will have an error. You have an error here that is, yeah. So what you need to do here, you need to say back here and then character. Varchar maybe 5 characters, maybe 10 characters. Some department, cyber security is longer than 5. So that name text varchar, primary key, check the mutual text. Oh, here text. All right. Then it is created. Once it is successfully created, then you can see the description of that table. In other words, that is a schema. How can you see the schema on MySQL? What is the language? Then you say describe, or DESC in short. Oh, sorry, DSC, and then you can see the department. Then you can see that, okay? The field, we have 3 fields, right? And then type of that is type for text, type for name is text, type for chair is text, type for DID, varchar, 10 bytes long. Can it be null? Name can be null, chair can be null, but DID should not be. When you create department ID first exists. Name could be next. And then the key, this is a primary key. I'm not sure why I said. Then DID may not be cybersecurity, but in short, maybe CSEC, that's for department ID. Name for CSEC, we can say cybersecurity. Okay, clearly? So we can create like this, but right now, who is creating this? Root privileges creates, right? Root user creates this. So at this time, we want to create a user. Create user, and I can say Jayun525 at localhost identified by, again, Jayun525 and semicolon. Oh. This is not. So I want to copy and paste this. It should say create user, not use. Create user. That is created. Then I need to do grant all privileges. Plural, all the privileges, start, all the privileges on star to 525 at localhost. Hit enter. So I can create, I can give grants, I can do anything because I said all the privileges. I can do anything on any database, on any table, okay? And I want to quit this and come back again. User is Jayun 525 and password 525. I can get in. So show databases. There's a psi 525. I want to use psi 525. See the tables. I have one tables. Now I need to create another table called the student, and the student CWID is integer. And if you want to say I want to declare this as a primary key, you can make this primary key at the end. Well, let's do that at the end together. You can do it here. Primary key. So CWI is primary key. And the name, you can say text and major. Here's very careful. If this major is a foreign key and DID is your primary key in its original table, then type for the primary key and the foreign key, corresponding primary key, and then the foreign key should be the same. Because I declared that varchar 10, I need to say this way. And after that, you already said the primary key. And then foreign key. Foreign key is major, reference to department, and the ID, close, and another close, semicolon. Then it creates. So show tables. I have two tables. If I want to see the schema of a student, then I can get that, right? So here, CWID is a primary key. Major is a foreign key. It's a mutual reference, so-called. Okay. Foreign key could be null. If it is, although major is a foreign key, reference to the department DID. But initially or temporarily, some students may not declare the major, so it could be null. That's what it is here, right? That's reasonable. And then I want to say here, class, then a CRN. Let's say this is a CRN. And then title and instructor. So I can do create table, class, and CRN. There's also integer, title, text, instructor. There's also text. Primary key is the CRN. Semicolon. Then I have three tables. And schema of the class is CRN, there's a primary key, and title and instructor. So we have a class, department, and students. Now, finally, we want to create a table enroll. So which students enrolled in what class? That's what we want to see here, right? So that's the CWID. That is, we say that is integer, right? And then CRN. I want to put here CID. So different names about CID here is the same as the CRN here, class, right? Because I said CRN in the class table. But in enrollment table, I can change this CID. That's fine. Different name. Not necessarily all the same name, CWID, and therefore originally CWID. Like this, major is the attribute name for students, but actually that is the DID in the department. Similarly like that. So CID is also integer. And then you need to say foreign key. Foreign key CWID, references, CWID is student, right? Student CWID, comma, another foreign key. Foreign key CID, references, class, CRN, and another close parenthesis and semicolon. Boom, good. So DSC enroll, then we have that. Both CWID and CID are mutual. Now we want to insert. Again, if you want to insert the student first, student CWID 1111, name, say Bob, and major, we can say simply cyber. Cyber is the CID, department ID, real name for the cyber. We can say cyber security. See what happens. 1111 the CWID, that is a primary key, so we create 1111, fine. The name for that CWID is Bob. Major, that is the value should be dependent on the value in the department. But let's say try to do with this, then have an error, right? It says didn't say. I don't know why this guy says anything about that. It should say the mutual. So let's say if we want to populate the department first. So department name is cybersecurity, and DID is cyber, and then chair is Chen. Enter. Insert into it. Oh, sorry. I didn't put values. So I want to put here values. Let's go back to the one previous. See if, because I didn't declare cyber first to see what happens. Then this guy says foreign key issue, right? This is clear, the error messages. So now we want to do cybersecurity, that, and here again, department, followed by another keyword, values, enter, then that is entered. So if I do select, start from department, then I see the name of the department is a cybersecurity, CID is a cyber, and the chair is Chen. Therefore, we can create any students in cybersecurity majors. So create, insert into student values, and then we can say CWID, that is integer, name, as I said, the Bob, and major, cyber, then you can get in. But if you want to do CS, then you cannot get in because it's, first of all, there's a mutual. This is a primary key. You want to put the same primary key. This guy says there's a primary key, although it is not the primary key is not violated, but let's see this foreign key. CS is not created. Therefore, now the error message is about the foreign key. Okay. So to make a computer science department, so department ID is a CS, and chair, let's say William. And then the name of the department is computer science. Hit enter, then that is created. And back into this, for example, Bob. Bob is try to get in the CS, so that is okay. So right now, if you want to see the students table, then two students, Bob and Bob. So first Bob, different CWID in the different major. Fine, right? And then we can insert more students. And then Chris CS. And then cyber, maybe one more. 9, Peter, cyber. Start from student. Then we have 5 students enrolled. And they are in one of the 2 departments. We need to create a class. So now populate the class. Insert into class values. And then the CRN. I want to put the same ones. 525. Title distributed database. And instructor John. You can make that. Successfully get in. And then you want to do, this is 505. Then that is foundations of cyber security, right? Fine. You may do, can I make a one record one record at a time, or can I put multiple records in one statement? Let's try to do that. Okay, so 505, let's say 545, that is distributed developments, distributed software developments. That is a computer science course which I am teaching right now. That's one records. If we want to continue to add, then you can put the comma and more. Let's say 530 forensic, and it's taught by Usman. Close. That is the second ones, and third one maybe let's say 500. Okay, that is I think intro cyber, that taught by Chen. You add more and more like this. Okay, so I want to stop here. and then hit enter. Then 3 records entered in, and select from class. Then we have 5 classes. So now we are ready for students to register. So insert into enroll values. Let's say student 1111. Would like to enter, let's say 500, and 1111 also enter 525. 1112 enter 545. Let's say students 1112, another 1119 Peter. So 1119 Peter takes 530, and hit enter. Then we 4 registrations. Select start from, enroll, then 4 registrations. All right. So in this way, database can be created. So creation is done, right? Data populated. Now we are ready to access the database. We can also change some definitions if we want to. So all that data manipulation, not the data definition. We done data definition. So data manipulation will come next week. All right. By that time, I want you to get your database ready, so that we need to do data manipulation next week. So your next homework assignment is the population, the database creation and population, like I did today. All right. All right. I'll see you next week. Have a good one.